Zoax.net. Lesson 13. Creating Matrix Style Effects. To follow along with this lesson, create an empty console project and add a file named main.cpp to it, as we did in Lesson 1. In this lesson, we show how to use the prior programming lessons to create matrix style effects. This is a great application of random number generation since it gives a nice visual representation. We are going to build up the algorithm in stages to better explain the individual pieces. At the top of the program are two functions. We explained functions in C++ Console Lesson 12. The first function is called modulus, and we use it to calculate remainders. That is, if we were to divide in by imod, this function returns the remainder of that integer division. For example, if in equals 14 and imod equals 3, then iq is calculated as 4, and we have a remainder of 2, which is what the function returns. We can write the relationship as in equals iq times imod plus the remainder, or in this case, 14 equals 4 times 3 plus 2. The value we return is the remainder, which equals in minus iq times imod, or 2 in this case. Our next function is called getChar and uses the value of the argument iGenerator to return a char value in the range from cbase to cbase plus irange minus 1. Here we use our modulus function to map the generator value to a character in the given range. For example, if iGenerator equals 28, cbase equals a, and range equals 26, then the modulus function returns the value 2 for our remainder. So the function getChar returns a plus 2, which equals c in our ASCII table. The modulus is used frequently in computer programming and serves as the basis for most random number generators. This particular usage is very simple and should give you a sense of how random numbers are generated. In our main function, we use the constant true as a looping condition to loop forever. Inside that while loop, we have another loop which outputs an entire row of 80 characters. To do this, we call getChar with the range of characters from exclamation point to greater than. We could use most any range, but this works well, and the formula j plus I squared gives a reasonable randomization for our purposes. We add 31 to the value j at each loop. Notice that we have declared j outside of the while loop so that it remains in scope and retains its value. We covered scope in C++ Console Lesson 11. Again, 31 is just a value that works well. We will not get into the theory behind it here. However, you can try changing the values and see what happens. Finally, we have a loop that we will call to slow down the output. The proper loop value will be different depending on how fast your computer is. For me, I call getChar 300,000 times, and this slows down the output after each row. If we execute the program, we see what looks like random garbage. In the screenshot, we can see that there is a slightly visible pattern. By the time we finish, however, there will be no noticeable pattern. The actual matrix effect has streaks of characters and spaces in it, so we'll make some adjustments to create this effect. First, we add an array which will be used to store the value of each character in the row that we output. We covered arrays in C++ Console Lesson 10. Next, we'll change the characters only at the locations where a character already exists. We'll leave the spaces as spaces to create the streaks. Finally, we add 3 more integers that we will use to start and end the character streaks. Each of these integers is updated with a different value. We use the j and l values to start new streaks, and k and m to end character streaks. We use the modulus function for the indices to keep these values in the range 0 to 79 as we require. Now if we execute the program, we see a much nicer matrix effect. This code is available on our C++ Console Lesson 13 page at zoax.net. To make the effect more accurate, we could color the text like this. Unfortunately, this requires Microsoft-specific commands. Since this C++ console series is intended to be platform independent, we will cover this additional step in our C++ miscellaneous series.